Hello friends, I am Saurabh. Today we are going to do a deep dive into very common yet confusing topic, locks in intersystem cache object scripts. In this training we are going to cover from the basics to most complex and confusing aspects of locks. Talking about prerequisites, I believe all the folks who are aware about MUMPS and Caché Object scripts will be an appropriate candidate for this training.
In this training, firstly, we will try to understand what is data corruption and how locks are important. Then, we will jump to a section called Global is Locked, where we will clear some misconceptions on lock and see what is the difference between locking a global and locking a variable. Then, we will see what is the recommended convention and why is it so. Then, we will try to implement Singleton design pattern with locks. After this, we will have a quick look on locking syntax, following by the difference between incremental and non-incremental locks. Then we will see how locks can be classified. And finally, a deadlock situation. This training will going to be a bit long as we are going to do a deep dive on each and every topic with some interesting examples. I guarantee you that by the end of this session, each and every concept regarding locking will be crystal clear to you. If you have any question, please don't hesitate to write to me. So, let's start. First of all, we are going to discuss why we need lock. The answer is to be safe from data corruption. So, next question strikes to our mind is how? Let's try to understand this with very simple example. We need to populate a global square of number in a way so that it holds the value of square of its node value. For an example, square of number n should equal to n into n. Square of number 1 should equal to 1. Square of number 2 should equal to 4. Square of number 3 should equal to 9, and so on. Global square of number without any node should hold the value of its largest node. For an example, if last node of square of number is 5, means the last node is square of number 5 equal to 25. Then square of number should equal to 5. So now let's see the code which populates this. I have created a simple class for data entry, training, logs, data corruption, without log, data creation. In this class, we have not used logs. Let's go through code. In line number 6, global square of number, increment square of number equal to corrupted. Increment square of number and creates a node value with corrupted. In line number 7, halt not square of number mod 5 1 will halt the code for a second if square of number is divisible by 5. We have done this to replicate a scenario where we call an external API for some calculation and it has taken some time to respond. And then finally we populate square of number. So by seeing the code, we can say that global square of number n will initially set to corrupted in line number 6. And then we are setting the value n into n in line number 8. By seeing this code, we can say that there is no margin of error if a process executes this code. But what will happen if multiple process executes this? I have created another class training logs data corruption without lock threaded interface to replicate that 5 users having different jobs are doing data entry for 100 records. We can see that we have 5 jobs in method call 5thread, and in method populate without log we are checking that total number of records stored in global square of number is more than 100. And then finally we are calling our data creator class. Class training logs data corruption check data integrity will check whether the data which is entered is correct or not. That is, will check whether the data what is stored is what we have intended. Means square of number n should always equal to n into n. So in line number 7, we check whether the data entry is completed or not. And in line number 15, we check data integrity. If data integrity fails, then we are showing the corrupted data. I have opened a terminal to execute this code. To create data, we will call training logs data corruption without lock threaded interface call 5thread. This will replicate a scenario where 100 records are created by 5 different users randomly and independently. Now we will check whether the data is correct or not. We will call class training logs data corruption check data integrity dot check. So we are able to see that some data are not correct. So this is what the data corruption is. So why this has happened? As data is entered via 5 independent threads or jobs, we don't have control on the sequence of data creation and thus data got corrupted. Let's now see with the help of logs how we can solve this issue. I have created a new data creator class training logs data corruption with log data creator, which is very similar to the earlier data creator class, except we have implemented very simple lock. Here in line number 6, we have locked square of number, and in line number 10, we have unlocked it. I have also created training data corruption with lock threaded interface, which is also similar to the earlier threaded interface class, except now we call our new data creator class. Now we will create data again. We will call class training logs data corruption with log threaded interface call 5threads. Now we will check that data is stored as we have intended. We will call training class data corruption check data integrity dot check. We can see that data is not corrupted now. Let's now see how logs helped us to get rid of data corruption. I have opened 2 terminals. Each terminal have different job. We can do write $J in both the terminals to find that job ID is different. Let's lock square of number in both the terminals. In terminal 1, we will do lock plus up arrow square of number, and also in second terminal we will do the same. We can see that terminal 2 is hanged, means job ID 2 is in pause state. And when we release lock from terminal 1, L minus square of number, we can see that terminal 2 is back active. This means that lock of second terminal waits until lock of first terminal is not released. Thus, in class training locks data corruption with lock data creator, data is data will be written sequentially in global by multiple jobs as we have used locks. So now we have an idea what data corruption is and how we can prevent it with the help of locks.
Till now, we have understood the basic idea behind locks. Seems to be very simple, right? There are many other aspects of locks, and we are going to knock out each and every of it one by one. Let's have a deeper dive in these.
Global is locked. Is it true?
I have taken lots of technical interviews in my career, and when I ask candidate, what do you mean by lock caret patient? Lots of folks have replied that patient global is locked and we cannot modify it until unless it is not released. Is this correct? The answer is no. The global cannot be locked directly. Confused? Let's try to understand this with an example.
We have opened two terminals, means we have two different processes. Now in first terminal we will perform lock in a global and then update the value of it. So we will write lock plus caret patient, and then we will do set global patient is equal to Saurabh. Now we will see if any global which is locked by a process can be modified by a different process or not. So in the second terminal, which is our second process, we will modify the value of patient global. Set patient is equal to set. Let's see whether the value is properly set or not. It's properly set. So this means that we can modify a global in a process even if it is locked by a different process. Also, in this statement lock caret patient, caret patient is just a lock name and it has nothing to do with actual global patient. Locks and globals are totally independent. We keep lock name same as global name in order to follow convention. It is not forced. However, in later slides, we will also discuss why we have such convention. So in our earlier code class training logs data corruption with log data creator, we will replace L plus square of number with L plus Saurabh. Note we have not used caret here. And L minus square of number with L minus Saurabh. And we will compile this code. It's compiled. Now we will open the terminal and create data again. D class training logs data corruption with log threaded interface call 5 threads. As we know that this will create 100 records via 5 different jobs. Now we will check whether the data is created properly or not. So we will call D class training logs data corruption check data integrity dot check. So it returns that data is not corrupted. This means that even if we have modified the log name as Saurabh, it has given us the same result. My main intention for this section was to explain that there is no direct relation between log name and global name. But we should always follow convention and keep log name and global name same. Why we have such convention?
According to convention, global name and log name should always be same, and log should always have caret. One obvious reason is to identify the global for which log is applied. Is this the only reason? Let's jump to another interesting demo to find out the answer.
Let's open view log page. So in management portal, we need to navigate to system operations, logs, view logs. Here we are able to see the log across all the namespaces. Owner columns tells us what is the job ID which has executed the log. Directory columns tells us which directory the log information is present. We have opened a terminal and its job ID is 15520. Currently, we are in samples namespace. If we want to know what is the directory of the database sample namespace is pointing to, we have to do d caret %dir. So we can see that default directory for sample namespace is InterSystems share manager samples. Okay. Let's log without caret. So we will log. So without caret is just a log name and we have not used caret here. Now in view log page we can see without caret. Also we can see that the owner is 15520, which is same as the job ID of terminal 1. And directory is C intersystem health share mgr. Something is fishy. This is not the directory from where we have executed the log. We have executed the log from samples and directory is C intersystem healthcare manager samples. Let's try this one more time. We have opened a new terminal and its job ID is 20852. We are in ENS demo namespace and the default directory is C InterSystems Hellshare MGR ENS demo. Let's lock without caret again. It's hanged. Let's check in view logs page what has happened. In view logs page, for owner 20852 and reference without caret, the status is wait exclusive exact, means it is waiting for another process to release the log. But this log we have executed from ENS demo namespace, right? Aha, here is the reason. The directory is C InterSystem Hellshare Manager MGR, which is same as the earlier one. So we can conclude that when lock name don't have caret, lock is not created in the directory pointing to the current namespace. Rather than it is created in the directory pointing to %sys namespace. So in terminal, if we do zn to %sys namespace and do d caret %dir, we can see the directory is C InterSystem Hellshare Manager, which is same as this one. If we want lock which is applicable for all namespace, we should not use lock caret in lock name. But this is very rare scenario. Let's now see what happens if lock name is prefixed by caret. In terminal 1, we are in samples namespace. Now let's lock caret and we will use lock name as with caret. Now in view log page, we can see with caret as reference and directory is C InterSystem Hellshare Manager Samples. Please note that here the directory includes samples. This is the directory which is corresponding to the samples namespace. Let's do the same from different terminal and from different namespace. Here we are in ENS demo. We will do lock with caret. Unlike last time, this time we can see the lock is attained. Now in view logs page, we can see another reference with caret whose directory is C InterSystem Hellshare Manager ENS demo. So here we can conclude that when we use caret with the lock name, the lock information points to the directory of the namespace where lock is executed. As here we can see reference with caret, we have two different locks corresponding to ENS demo and samples respectively. Now let's see another example where lock name is same as global, which is mapped to a different database. We need to navigate to namespaces pages. We can go there by administration, configuration, system configuration, namespaces. Then we need to select global mapping link against samples namespace. We can see in sample namespace mapped global is pointing to ENS demo. This means that for any read and write operation on map global from sample namespace will actually happen in ENS demo database. Sample names database will not hold any data of map global. Now in terminal 1, where we are in samples namespace, we will lock mapped global. We have to use caret here. Okay. Now in view logs page, we can see map global directory is C InterSystem Health Share Manager ENS demo. So in case of mapped global, lock is created actually in the database where global is mapped, not from where the lock statement is executed. So concludingly, we have a freedom to use any lock name, but if we want to control access of a global via lock, we should always keep the lock name and the global name same. Let's see how we can implement singleton design pattern with the help of locks.
We will now try to implement singleton design pattern with the help of lock. As we all knows that singleton pattern is a design pattern that restricts the instantiation of a class into one object. Means by this pattern we can restrict to have only one object of a class across the system. Let's jump to a demo.
I have created a class which implements singleton design pattern. Class training logs singleton pattern. In method on new, line number 8 plus caret $log singleton pattern owner will return the job ID where log singleton pattern is applied. Singleton pattern is just a lock name. This will return 0 if there is no such job ID. Then we will apply lock on singleton pattern. Otherwise, we will return an error. In method %onClose, which is called when the object is released from the memory, we are unlocking singleton pattern. Please note that I have set lock name as singleton pattern without any caret sign, as code can be shared to multiple databases via package mapping. As here I want that there should be only single object of this class across all the process and across all the database. If you want single object for each class, then here we should use caret, that is caret singleton pattern as explained in my previous sections. I have opened terminal 1 with job ID 6212 and will try to create the object of our new class. So we will write set obj equal to training lock singleton pattern dot percent new. Let's see whether the object is created or not. This returns once, means object is created. Now let's create a new object of the same class. So we will write set new obj equal to class training lock singleton pattern dot percent new. Let's see whether the object is created or not. This has returned 0. means object is not created. Let's see what the error was. So the error says that active object of this class is already present in the process 6212. This means that in our code plus caret $lock singleton pattern owner has written the job ID where lock on singleton pattern is applied, and thus we have got this error. Now let's create another object from a different process. I have opened terminal 2 and its job ID is 10864. So we will try to create the object of the same class again. So here we have done new obj is equal to class training log singleton pattern dot person new, and then we will check whether the object is created or not. This has returned 0, and when we check the error by write $system status get error text %obj last error, it has said that active object of this class is already created and its process is 6212. Thus, we are not able to create the object of this class even from the different process, as we have already created the object which is still active in terminal 1. Now we are back in terminal 1 again, and we will release the object from the memory. That is, we will kill this object. We will just write kill. And in terminal 2, we will try to create the object again. So we'll do the new object is equal to class training log singleton pattern person new, and then we will check whether the object is created or not. This time this has returned 1. Thus object is created, as there is no active process which has hold the lock on singleton pattern. This is the way we can implement singleton pattern in cache objects via locks. Thus, a part of locking global, we can do other cool stuff from locking. Let's talk about basic of lock syntax. Lock will delete all locks attained by a process. Lock space lock name will clear all previous locks present in the process and attain new one in lock name. Lock space plus lock name. Incremental lock on lock name of same process. So the difference between lock space lock name and lock space plus lock name is, without plus sign there will be always a single lock in lock name. But if you use plus sign, then multiple locks can be attained on lock name via same process. We will be discussing this more in the further sections. Lock minus lock name. Decrement locks on lock name of same process. We will be discussing this also. Lock space lock name colon timeout. Try to attain the lock for defined time period mentioned in timeout, and will not be in hang state if it is not able to attain lock after the timeout is crossed. Lock space lock name hash lock type colon timeout will attain lock on specific lock type for timeout for time period defined in the timeout. We will be discussing about lock type in the further sections. Lock space minus lock name hash lock type. Decrement lock of specific lock type. Incremental versus non-incremental locks. Let's try to understand difference between incremental locks and non-incremental locks with an example. We have opened terminal 1 and its job ID is 15116. Now we will lock global Tom. L caret Tom. In view locks page, we can see lock is attained by job 15116 on reference Tom. Now we will lock global blah. L caret BLAH. We will refresh view lock screen. In view lock page, we can see that lock is attained by job 15116 on reference blah. We cannot see any lock on reference Tom now. So what does this means? Lock space lock name has cleared all the existing locks and attained a new lock on lock name. Here the lock name is blah. Now we have opened terminal 2. We can see its job ID is 11044. Now we will lock again blah. Lock global blah. We can see that terminal 2 is in hang state because global blah is locked via terminal 1. Also in view locks page, we can see that lock via terminal 2 is in wait exclusive exact state. We can check the job ID 11044. This means that this is in queue state. In terminal 1, we will lock blah again. We can see that now terminal 1 is in hang state. And terminal 2 has attained lock on global blah. Also in view locks page, we can see job ID 11044, which is the job ID of terminal 2, has attained the lock on reference blah, and job ID 15116, which is the job ID of terminal 1, is in wait exclusive state. So what has actually happened when we lock blah second time in terminal 1? Lock blah has first released all the locks in the process and then try to attain new lock on blah. But as terminal 2, which was already in a queue state, attained the lock on blah. So this is how non-incremental locks works. Now let's see how similar scenario will work in the case of incremental locks. In terminal 1, we will do incremental lock on Tom. So we will do lock plus caret Tom. We will refresh view logs page. So in view logs page, we can see that lock is attained by job 15116, which is the job ID of terminal 1 on reference global Tom. Now we will do incremental lock on global blah. Lock plus caret blah. We will refresh ViewLogs page again. Now in ViewLogs page, unlike non-incremental locks, we can check that lock is attained by job of terminal 1, that is 15116, on both the references global tom and global blah. So when we use plus sign, it does not releases all the lock in the process. Now in terminal 2, we will lock global blah. Lock. We will do incremental lock. So we can see that terminal 2 is in hang state as global blah is already locked by terminal 1. Also in ViewLogs page, lock via terminal 2 is in, we will refresh the ViewLogs page. Okay, so lock via terminal 2 is in wait exclusive exact state, means it is in queue state. Now in terminal 1, we will do incremental lock on blah again. So terminal 1 seems to have attained lock on blah, whereas terminal 2 still in hang state. We will refresh ViewLogs page. So we can see that exclusive/2 lock is attained by the job of terminal 1, that is 15116, on global blah. Whereas lock on global blah via terminal 2, that is 11044, still is in wait exclusive exact state. Now we will again do incremental lock on global blah from terminal 1. Refreshing the ViewLogs page. So now in ViewLogs page, we can see that exclusive/3 lock is attained by the job of terminal 1, whereas terminal 2 is still in wait exclusive exact state. By exclusive/3 lock, we can say that 3 locks are applied on global blah by a process corresponding to terminal 1. Now we will unlock global blah from terminal 1 using minus sign. So we will write lock minus global blah. We will refresh the ViewLogs page. Terminal 2 is still in hang state, but we can see that exclusive/2 lock is now applied on global blah by the process of terminal 1. We will again unlock global blah. Refreshing the screen. We can see that terminal 2 is still in wait exclusive exact state, and exclusive lock is attained in global blah via terminal 1. So here we can see that terminal 2 is still in hang state. In terminal 1, let's do the same one more time. So finally, we can see that terminal 2 is not in hang state, means it is able to acquire lock. And we will refresh the ViewLogs page. So we will not find any locks attained by the job of terminal 1 on on global blah. So the job of terminal 1 as we remember was 15116 and it's only in global tom. But in global blah the job ID is 11044. So this is the difference between incremental locks and non-incremental locks. So what we have understood from this: incremental lock never perform unlock. Rather, it tends to apply another lock on over the same lock name when repeated. Until and unless all incremental locks against a lock name in a given process is not released, we cannot perform lock against same lock name in another process. If you guys still have confusion on this, press the pause button and just work out on the same example as in your terminal. Classification of lock type. Locks can be classified by splitting into two parts: exclusive and shared. This can be further splitted again into two parts: non-escalating and escalating. So locks can be classified as exclusive and shared, non-escalating and escalating. In actual world, these are always works in pair. A locks can never be only exclusive or shared or non-escalating or escalating. First pair is exclusive non-escalating. This is a default pair, so we don't have to specify anything in lock type. Since this is exclusive, this should be used only where you are performing write operation, that is updating or inserting a new record in a global. We will be discussing in detail in upcoming sessions. Since this is non-escalating, this should be only used where probability of locking large number of nodes under the same array is very less. Again, we will be discussing this in detail in upcoming sections. Second pair is shared non-escalating. We need to specify lock type #s while locking or unlocking. Since this is shared, this should be used only where you are performing read operation, that is only view data. We will be discussing this detail in upcoming slides. Since this is a non-escalating, means this should be used only where the probability of locking large number of nodes under the same array is very less. Third pair is exclusive escalating. We need to specify lock type #e while locking or unlocking. Since this is exclusive, this should be used only where you are performing write operation. Since this is escalating, this should be used only where probability of locking large number of nodes under same array is very high. Fourth pair is shared escalating. We need to specify lock type #se while locking or unlocking. Since this is a shared, this should be used only where we are performing read operation. Since this is escalating, this should be used only where the probability of locking large number of nodes under the same array is very high. In all the sections, you are able to see immediate and deferred unlock. These are two special unlocking mechanisms which can be tied to any lock while performing unlocking within a transaction. For immediate, we need to specify #i. For deferred, we need to specify #d. We will be discussing this again in the further slides. Now, We will do a deep dive with examples on classification on locks. Exclusive versus shared. Let's first create a dummy data in a global. I have opened a class training locks exclusive versus shared trainee data creator, which will create dummy record for us. My global structure is very simple. Global name is trainee, node is trainee ID. It will consist of first name, last name, DOB, email ID, mobile number, address line 1, address line 2, city, state, country. So I will be creating a record with trainee ID 1 and data will be Saurabh Sethi 2201984 Sethi Saurabh.hit@gmail.com 1111111 B16 208 Super Heights Kharadi Pune MH India. Let's open terminal and create this record. We will do write class training logs exclusive versus shared trainee data creator dot create. We can check the global the upper person G. We can see that the global the record is created. Now let's see the class which is responsible for reading the data. Our class name is training logs exclusive versus shared read data. In this class we have used shared log in line number 6, log trainee hash s colon s, and if shared log is successful we are determining via $test and then we are reading the data. In order to interpret real-time scenario, we have used read OK in line number 15, which will hang the process until unless we do not press enter. Means this global will be locked until unless we don't press enter. Let's see another class which is responsible for writing the data in global. Training logs exclusive versus shared write data. In this class, we have used exclusive log in line number 6, log trainee colon 0. And if exclusive log is successful, then we are determining via $test and we are updating the mobile number. Which is actually a write operation. As we have done in another class, we have done read OK in line number 14. Hope you have understood these classes and now it's action time. So first we will read the data from different processes, that is from different terminals, and then we will try to update the data. You can see I have opened 5 terminals. In terminal 1, 2, 3 and 4, we will try to read the same data. So we will do write training logs exclusive versus shared dot read data dot get data 1. We can see that execution is paused as it is expecting to press any key because we have used read OK. All we want is not to release the lock. So we are doing same in the second terminal. Third one. And finally the fourth one. So just to remind you that while reading the data, we are using shared log. So we can see that in terminal 1, 2, 3, 4, we are able to read data and output is same in all 4 terminals. From this, we can understand that
When we have applied shared lock on trainee lock name, we are able to apply another shared lock on same lock name via a different process. Thus, we can say that using shared lock, we can read same value from multiple process. Now, let's see whether we can write in disk while reading it, or more technically, can we attain exclusive lock on same lock name if it is locked as shared lock by different process? So in terminal 5, we will do write training locks exclusive versus shared, write data, update mobile number 1. Enter. It returns unable to acquire exclusive lock. So we can also conclude that if shared lock is applied to any lock name via a process, then we are able to apply multiple shared lock on the same lock name via other process, but we are not allowed to apply any exclusive lock on that lock name via any process. Thus, we can conclude further that if we use lock properly, with the help of shared lock, we can read data of a global from multiple process and restrain writing on that global. Now, now let's do other way around. We will now check whether we can write data via multiple process at same time and whether we can read data if we are writing data from different process in the same setup. I have terminated all the terminals we have used via reading demonstration and opened two fresh terminals. In terminal 1, we will do write class training logs exclusive versus shared write data dot update mobile number 1. We can see that exclusive lock is attained. Do not press enter now as we want that this lock should be active for further demonstration. In terminal 2, if we write the same command to update, means write class training logs exclusive versus shared write data dot update mobile number, it says unable to acquire an exclusive lock. From this, we understood that when we apply exclusive lock on trainee lock name, we are not able to apply another exclusive lock on same lock name via another process. Thus, we can say that using exclusive lock, we can restrict writing on a global via multiple process, which is very logical. Otherwise, it will tends to create corrupted data. Let's see whether we can read the data while writing on the global, or technically whether we can acquire shared lock if exclusive lock is already active via another process. So in terminal 2, we will do write training logs exclusive versus shared read data dot get data 1. It says unable to acquire shared lock. Means if exclusive lock is applied to any lock name via a process, then we are not able to apply exclusive lock or shared lock via any other process. Thus, we can conclude that if locks used properly, with the help of exclusive lock, we can restrain other process to write or read data. I hope now we have a clarity on shared and exclusive lock, and we also understood that where we should use it. Escalating versus non-escalating. As we have already discussed, we should use escalating locks where probability of locking large number of nodes under the same array is very high, and when it is low, we should use non-escalating locks. But how we will define that number is very high? Obviously, there is a configuration for this. Open Management Portal and navigate to System Administration, Configuration, SQL and Object Settings, General SQL Setting. In log threshold, you can see that default is 1000. For demo purpose, I have set this value to 3. So, what is the significance of log threshold? Within a process, if we use escalating locks on different nodes of same array, then till threshold limit is crossed, in log table we can see separate locks for each node. After threshold limit is crossed, we can see one common lock for all nodes with a number, which will tell you how many nodes are locked. So when we are dealing with lots of nodes of same global under same process, escalating lock will help us not to make lock table full. There are two main things we have to keep in mind while working with escalating locks. Same process, all the nodes of the array should be locked under same process. So how we can lock multiple nodes? Definitely we have to use incremental lock. So we have to make sure that we use plus sign while working with escalating locks. Otherwise, it will work as non-escalating locks. Now let's do a deep dive on escalating locks and understand how this works. We are in View Logs page. In this section, we will see how normal locks, that is non-incremental locks, works with array. I have opened a terminal, and in this terminal we will lock a node of an array. Lock caret test array node 1. Now we will check in View Logs page, and we can see that there is an exclusive lock on test array node 1. Now in the same terminal we will lock the second node of that array. So lock test array node 2. In View Logs page, first we will refresh it. We can see that there is an exclusive lock on test array node 2. However, previous lock on test array node 1 is not present. Now we will lock test array node 3. In View Logs page, we will refresh it. We can see that there is an exclusive lock on test array 3. However, the previous lock on test array node 2 is not present. From this, we can conclude that when we use non-incremental lock in an array, it releases the previous lock on that array, no matter even if the nodes are different. Before jumping to escalating locks, let's revise how incremental locks work with array. First of all, we will clear all the locks, so we will just write lock, and then we will apply 5 incremental locks on different node of same array. So we will do lock plus test array node 1, lock plus test array node 2, lock plus test array node 3, lock plus test array node 4, and lock plus test array node 5. Now in view logs page, we can see that there are 5 exclusive logs on test array 1, test array 2, test array 3, test array 4, test array 5 by same process. If you remember, we have set locking threshold as 3. Here we cannot see any of its impact. Let's now see how locking threshold works with escalating locks when we are dealing with array. First of all, we will clear all the locks. So in the same terminal, we will apply escalating locks on 3 nodes of same array. So lock plus test array node 1 hash e, lock plus test array node 2 hash e, lock plus test array node 3 hash e. We will now check in view lock page. We can see that an exclusive underscore e lock is present in test array 1, test array 2, test array 3 and test array 1, test array 2 and test array 3, which is an escalating lock. So how is it different from exclusive lock explained in the previous example? So remember, in the slide I have told that I am setting threshold value to 3. So now we will cross the threshold. So in same terminal we will do lock plus test array node 4 hash e. So we are trying to attain escalating locks on the 4th node. Let's see what happens in the terminal. Let's see what happens in the view logs page. First we will refresh it. We can see that exclusive 4e lock is attained in test array. Let's do the same for the 5th node in terminal. In view logs page, first we will refresh it. We can see that now exclusive 5e lock is attained on test array. So from this we can say that exclusive escalating locks are present in 5 different nodes of test array. So now what will happen if we do lock plus test array node 5 hash e again? Answer is simple. Since it's an incremental lock, it will try to attain another lock on this node. So this will be exclusive 6e lock on that test array. So we will go to view logs page and refresh it again. We can see that this is now exclusive 6e lock. Now in terminal we will release lock one by one. So first we will release lock for first 3 nodes. In view lock page, previously we can see that exclusive 6e locks is applied on test array. We will refresh the page. We can see that now exclusive 3e lock is applied on test array. So let's release the lock on node 4. In the view log page, we will refresh it first. Now we can see that exclusive 2e locks is applied on test array. So from this we can conclude that until and unless all locks on the array are not released, this pattern prevails. Hope now you have understood that how escalating locks works. Immediate and deferred lock. Unlocking in transactions. We are in View Locks page. First of all, we will see how normal locks, that is non-incremental locks, behave in a transaction while unlocking. I have opened terminal 1 and we will start a transaction via start. Now we will lock and unlock any lock name. So we will lock test and then we will do lock, which will release all the locks in this transaction. So note, we are still in transaction as it is not committed or rollback. In View Locks page, we can see that mode count is exclusive dlock for test. Now in terminal, we will do tcommit. We will refresh the View Locks page. We can see that in View Locks page, test is not present. So we can say that when non-incremental locks are unlocked in a transaction, they move in delock state and they are released when the transaction is completed via tcommit. Now let's see how normal incremental locks behave in transaction while unlocking. So I am in terminal 1 and we will start as a transaction. So we will write tstart. Now we will add 3 incremental locks on test. Note, this is non-escalating lock. In View Lock page, we can see exclusive /3 lock is applied on test. Now we will unlock test one by one in the same transaction and check View Lock page. So here we will do lock minus test. We will go to View Locks page and refresh it. We can see that now exclusive /2 lock is applied on test. Note, it is not a delock state here. Now we will unlock it again to release the second lock on test, and in View Lock page we will refresh it. We can see still the mode count is not delock, the mode count is exclusive. We will decrement the lock on test further, and in View Locks page we will first refresh it. Finally we can see exclusive delock mode count against reference test. Let's try something else. At delock state, we will open a new terminal and try to attain lock on test. So this is a new terminal. Let's lock plus test. This is hanged, means it is waiting for some process to release the lock. In View Locks page, let's refresh it. We can see that there is a mode count of wait exclusive exact on reference test.
means it is waiting for first process to release the lock on test. Now in terminal 1 we will do t commit. In view logs page we will first refresh it. We can see that lock on test is released by a process corresponding to terminal 1, and terminal 2 has attained lock on test. So we can say that in case of incremental locks, delock state is attained only when the last lock on lock name. Only when we unlock the last lock on lock name. That is when the lock count is 1. And at this state, no other process can attain lock on that lock name. So what is delock state? Delock state is a state which is going to unlock after completing the transaction, that is via tcommit or trollback. But during that transaction, if any other process try to attain lock on that lock name, it will fail. Now let's see what is immediate lock. So as name suggests, this will do immediate unlock. So in a transaction, if we use immediate unlock on last lock of any lock name, that is when the lock count is 1, then it will not attain delock state and release the lock immediately. So I have opened terminal 1 and we will first start the transaction. Restart. Lock test. Lock minus test hash I. So in the previous section we have seen that when we unlock any lock name in a transaction, it will move to delock state if the lock count is 1. Now I will refresh the page here. I will not find any lock on reference test. Means hash I has immediately unlocked that lock and delock state was never attained. Now let's see what is deferred unlock. Deferred unlock is simply a copy of previous unlock behavior. That is, when we are using deferred unlock on the last lock, it can be immediate or can go to delock state depending on the previous behavior. Let's try to understand by a very simple example. We will first start a transaction, restart, and we will apply lock on test. It will be incremental lock, lock plus test, and then we will unlock it, lock minus test. We know at this state the state of lock is unlocked, so the state of lock is delock. We can see that there is a delock mode count on test. Let's do incremental lock again on test. So now here the delock will be gone and it will be an exclusive lock on test. Now we will unlock it, but this time we will do a deferred unlock. So we will do hash D, okay, and we will press enter and we will refresh this view lock page again. We can see that it is in delock state. Now let's do an immediate unlock. So first I will lock I will apply lock on plus test, or let's take a different uh, lock name. So I will do lock test 1. Okay. So here if we see on view lock page, we have an exclusive lock on test 1. Okay. Now we will just unlock it. So lock minus test 1. Actually we should do an immediate unlock. So we will do lock plus test 1, and then we will do lock minus test 1 hash immediate. Okay. So in view logs page, we will now refresh it. We should not find test 1. So test 1 is gone. Okay. So let's try to apply a deferred unlock on test 1. So for that, firstly we have to lock test 1. So we have applied lock incremental lock on test 1, and then we will do a deferred unlock. So remember last time when we have done deferred unlock on test, the lock went to delock state. Let's see how it behaves now. So here if we have done deferred unlock on test 1, we cannot see its reference. So it has copied the last behavior, which was immediate. This is all about immediate and deferred unlocks. Since till now we have gone through almost everything on locks, so it's time to jump on last section, that is a deadlock situation. I have opened two terminals. In terminal 1 we will lock Saurabh. Lock plus Saurabh. In terminal 2 we will lock Sethi. Lock plus Sethi. Now we will go back to terminal 1 and we will lock Sethi here. So since there is another lock on Sethi in a different process, this terminal is hanged. Now we will go to terminal 2 and we will lock Saurabh there. So since Saurabh is locked via terminal 1, the terminal 2 is also hanged. So this is a deadlock situation, as both the process are waiting for the other process to release the lock. Now you guys have to find out how to avoid such situation and how to solve this delock. Thank you.
Thank you for being part of this training. If you have any questions on Helshare Ensemble Caché Objects, please shoot out an email to me at sethisaurabh.hit@gmail.com. If you want to appreciate me, please share this video. Thank you.